So I'm going to start a new project. And this time I'm going to choose a CSP system so that I don't lose all of our CSP friends online. I'm going to model a parabolic trough system. So we've got a number of options under concentrating solar power. We've got 2 options for modeling troughs. And then we can model power tower systems, dish Stirling systems, and then this generic solar system is an option for those of you who have optical efficiency data. So if you have a set of optical efficiency values for different sun angles, then you can use this generic solar system to model any kind of solar system, any kind of system that converts solar energy into heat to drive a steam power block. For modeling parabolic trough systems, we recommend the parabolic trough model for most cases. The empirical trough model is a little faster than the physical trough model, and it's appropriate for modeling systems that have a similar configuration to the SEG systems in the U.S. The physical trough model is a little bit more flexible for modeling a wider range of system types. Again, once I choose an option under technology, SAM displays a range of options for financing. And in this case, we're going to look at a utility scale system. So this is a project, a power generation project. The PV system that we looked at before was a commercial project, which is a project that's on the retail side of a utility meter. So a residential and commercial project buys and sells electricity at retail rates. A utility project negotiates a power purchase price to sell as a generation project. For this example, I'm going to choose the independent power producer option. So this allows me to specify a target rate of return for the project, and then SAM calculates the first year power purchase price. So the IRR is an input, and the power purchase price is an output. If you want to calculate it the other way around and provide the power purchase price as an input and calculate the IRR as an output, then you can choose the first year bid price. These financing options are the same regardless of technology. So if you're modeling a utility scale PV system, you'd have the same options. Okay, and I'll call this one Trough utility. So SAM creates a case for me. Again, it's populating all of the variables with default input values. And we have the same set of inputs for the first few input pages. The climate financing incentives are the same as for the PV system. And then the input pages further down for specifying the system are pages appropriate for the parabolic trough system. I won't get into those details just yet because I'm still focusing on the financing portion of the model. I guess I should have kept the PV commercial case for as an example. So let me just recreate that because I want to show you the difference between the commercial inputs and the utility inputs on the financing page. So now I have two cases in my project. One is for a PV with commercial financing, and the other is for the Trough with utility financing. One thing I'll point out is that you can move these tabs around by clicking and dragging them. So if I want to put the PV case in the second position, I just move it, click and drag the tab. And so I want to compare the financial inputs for the two project types. This is the commercial project, and this is the utility project. And what you'll notice is that the inputs in the general category, taxes and insurance, and financing parameters are the same for the commercial and utility cases. And also the depreciation options are the same for commercial and utility. They're down at the bottom. I have to scroll down to see them. What's new for the utility case is this construction period inputs and these financial constraints and optimization options. Let me just go through all of these inputs quickly so you have a sense of what kind of data you need to prepare to run the model. So for the projects, regardless of what kind of project you're modeling, you need an analysis period, which is you can think of as the project lifetime, but it's the period over which you're going to be performing the economic analysis. There's an inflation rate. So SAM uses the inflation rate to calculate costs in out years. All of the costs that you specify are in year one dollars. So in order to calculate a cost in, say, year 5 of the cash flow, SAM would use the inflation rate. The real discount rate is the value that SAM uses to calculate the present value in the levelized cost of energy and other calculations. So SAM uses inflation rate to calculate out-year values in the cash flow and a discount rate to bring out-year costs back to present values. The nominal discount rate, this is a blue value. It's calculated by SAM. So it's the real discount rate adjusted for inflation, and you can see the equation in help if you press F1 or Command question mark on a Mac. Taxes and insurance. So these are tax rates and insurance rates. Federal and state tax are percentages that are calculated based on the total installed cost of the system and apply annually. The property tax is calculated in the same way. So a percentage of the total installed cost of the system that applies annually. And then the sales tax is a one-time cost that applies in year 1 and is calculated as a percentage of the total installed cost. And the insurance is treated in the same way as sales tax. So this total installed cost is a very important number in SAM, and it comes from the system cost page. This is where you specify the cost of both installing and operating the system. And there's a fair amount of detail in the cost in specifying the installation cost. So you've got these various categories which vary from technology to technology. So if we look at this cost page for the Trough system and the cost page for the PV system, you can see that the categories are different. So for the PV system, we have module, inverter, BOS, installation, labor. For the Trough, we've got site improvement, solar field, HTF, and so on. These categories are really for your own bookkeeping purposes. SAM doesn't pay attention to the details. It just uses the cost details to calculate the total costs. So this total installed costs down here is the number that is fed into the cash flow model. So how you specify the cost details is up to you, and you should use a system that makes sense for your project. SAM only uses the total install cost. So for the PV system, same thing. Total install cost is the important number. That's installation costs. For operating costs, so the installation costs are all occur at the beginning of the project, and then the operation and maintenance costs are costs that occur throughout the project, throughout the analysis period. And you can specify O&M costs either as annual costs in dollars per year, so just a fixed dollar amount per year. It can be an amount that scales with the size of the system, so dollars per rated kilowatt of system capacity, or it can be an amount that scales with the output of the system in megawatt hours, so dollars per megawatt hour. And then for CSP systems that have a fossil backup unit, you can also specify the cost of fuel for the fossil backup unit. You'll notice that the O&M costs also appear for the PV systems, and you should just specify a value of 0 for those values for PV systems, because PV systems don't have fossil backup, but were for some reason required from a programming perspective to include this value on all the cost pages. So that's a little confusing, but be aware that for PV systems, you should assign a value of 0 to the fossil fuel cost, and that it doesn't affect results. There's actually a little note that mentions that here in orange text. Fossil fuel cost is not applicable to PV or disk-drilling systems set to 0 for these systems. Should be in the habit of reading these orange notes that you'll see scattered throughout the interface. They have helpful information. Okay, so that's a quick look at the cost page. I should mention one thing about the costs for the Trough is that NREL did a cost study for parabolic trough systems that has been published and was used to populate these the costs for the Trough model. There's not a similar study for PV projects, but you can find out about that cost study by going to the SAM website. You can download the documents, and there's an Excel spreadsheet that accompanies that study that you can actually use to populate the input values on the cost page. And we'll examine that in more detail tomorrow when we talk about the Excel exchange feature, which makes it possible to calculate input values in SAM using Excel. So you can send values from Excel to SAM. So we do have the cost values for the Trough model are based on this study that you can read about. So the quality of these default values for the Trough model is, I would say, a little higher than for the PV model, where the default values are just very rough estimates that are not based on any rigorous study. Okay, so the lesson from the cost page here is that SAM only uses the total installed cost when we're looking at the capital cost, and that these operating costs apply to the out years of the cash flow. And let's just take a moment to look at the cash flow table. So base case cash flow. So I click the graph button to see the results, and then click base case cash flow. And I see strange values there, which makes me think that I need to run. So I just created a new case, and I'm trying to look at results before I ran the model, and that's why I'm getting these funky results and blank pages. So let me click Run. I have some results to look at. The simulation is being slowed down a little bit by the fact that I'm on the webinar. So typically the simulations will run a little faster than you see, but that, of course, depends on your computer speed and the project that you're running. Okay, so we're looking at the base case cash flow table, and if we look in the year 0 column at the after-tax cash flow amount, this is my investment amount, which is, so the total install cost for this system is $823 million. And the amount that the project has to pay in year 0 is $494 million. And the reason the amount in the cash flow is not the same as the amount on the cost page is that we're taking out a loan. So on the financing page, if we see the debt fraction amount here, it's 40%. So that means that we're borrowing 40% of the total install cost amount. So that's the amount that we see here. This is the amount. This is the equity portion of the initial investment. If we look at the O&M costs here, remember on the cost page we have 3 categories of O&M, well, 4 categories of O&M costs: fixed annual, fixed by capacity, variable by generation, and fuel. And if we look in the cash flow table, we can actually see what those amounts turn out to be on an annual basis. These amounts are calculated based on the values that I specified on the cost page, year 1, year 2, and so on. This system doesn't have fossil backup, so there's no fuel cost. Here's the insurance cost. So this insurance cost is calculated as a percentage of the total install cost. And so I have a 0.5% insurance percentage, and I can see the amount in the cash flow. So as you're looking through your results and trying to understand what's going on, this base case cash flow table is really useful. You can get your calculator out and explore what's going on. And of course, you can use the spreadsheets that I mentioned earlier. Okay, so to get back on track, I was comparing the financing input pages between the utility and commercial case. One thing that's on the utility financing page that's not on commercial is this construction period. And what the construction period allows you to do is to put in information about any loans that the project might require before the project begins operation during the construction period. And Sam will calculate an amount based on the parameters that you enter here, and report those. Where do we see those? I think we see those. all right, right here under so utility financing parameters. This is the total installed cost, and then Sam would calculate the interest during construction and adjust the principal amount. So the principal amount is the debt fraction times the total installed cost. This installed cost comes from the cost system cost page. And then if I were to specify costs during the construction period, Sam would add the interest during that construction period to the install cost to calculate the principal amount. So that's how the construction period costs affect your project costs. The other group of variables that applies to both commercial and utility projects is federal depreciation, and SAM allows you to specify up to 4 different kinds of depreciation, and these are all depreciation schedules that are allowed for under U.S. tax code. If you want to specify a different depreciation schedule, you can do that by using a custom schedule, or you can model a system with no depreciation. And the depreciation benefit may apply to federal and or state taxes. So the cash flow includes tax payments for both state and federal taxes. Okay, now moving on to the inputs that apply only to the utility case. So remember, the difference between a commercial and utility project is that the commercial project is buying and selling electricity at retail rate. So it might be a PV system on the top of a big box store, and it could be connected to the utility through a net metering agreement or through a time of use payment structure, and it's still buying and selling power at retail rates. The utility project, what you're trying to do is to determine for the price that the project needs to sell electricity in order to meet some rate of return requirement. So the utility financing page has options for specifying the return requirements. So you've got the minimum required IRR. So this will ensure that the PPA price, the electricity purchase price that SAM calculates, will provide at least a 15% return. And then you can also require a minimum debt service coverage ratio. So if you check this option, we've specified a DSCR of 1.4. This is going to ensure that that there's always you always have a debt service coverage ratio of at least 1.4. So for each year, that there's cash on hand to cover debt costs at a debt service coverage rate of 1.4 or greater. And you can also force the cash flow to always be positive. So in many cases, there may be some years where you have negative cash flow and other years where you have positive cash flow. But you can tighten your constraints to always require positive cash flow. So if you've got these other constraints checked as they are by default, you may, the rate of return that SAM calculates may end up being higher than the minimum value, because you may need to increase the IRR to meet the other constraints. These 3 constraints are all interconnected, and so you can do some experimenting with them to see how they affect your results. And you can also look again in the utility spreadsheet to actually see how the calculations are done. Again, the spreadsheet mimics the SAM's calculations using Excel formulas, and there's a little macro, or I guess it's a solver in the utility spreadsheet that does the process of searching for the solution that meets these assumptions. The financial optimization options are automate the process of choosing a debt fraction and PPA escalation rate. So typically these are values that you would might be trying to determine what is an appropriate debt fraction for your project, rather than you may not come in to the project with one in mind. If you choose the financial optimization option, for example, for debt fraction, that disables the debt fraction variable, and SAM calculates it as a result. So in this case, it's telling us that the optimal debt fraction is 60% rather than 40%. Okay, so here I just, let's see, I just created a Trough case, and I ran it just with the default assumptions. So the default location is Blythe, California, and I didn't change any of the other assumptions. And I can see that this project requires a PPA price of 29.5 cents per kilowatt hour. One interesting thing that we can do in SAM is to compare different technologies. So we just did a comparison between utility and Trough. What happens if I build a PV system at this site instead of a Trough system? So to answer that question, what I would do is create a new case. So on the case menu, click Create Case. And this time I'm going to do PV instead of concentrating solar power. And I'm going to choose a component-based model here instead of PV watts, so that you can see the difference. And then a utility project with IPP financing. We'll call this PV utility. Again, SAM is loading a set of default values for the PV case. So you'll notice that the default location for Troughs is Blythe, and the default location for PV is Phoenix. There's a database of default values behind the scenes that SAM loads whenever you open a new project. And so it just so happens that for PV, the default location is Phoenix, and for Troughs, it's Blythe. So I want to model this system in Blythe. So I'll choose the same weather file. For the Trough case, it's CA Blythe with a bunch of numbers after it. So the PV case, CA Blythe with a bunch of numbers. So now I have the same weather file. I can just confirm that by making sure that the summaries of the weather data match up between the two cases, which they do. And then our Trough system has a nameplate capacity of 100 megawatts. And for Trough systems, the system nameplate capacity is determined by the power cycle nameplate capacity. So here it is 100. megawatts is the nameplate capacity. So I want to build a 100 megawatt PV system, and to do that, I go to the array page and put in 100 megawatts as my desired array size. And when I move the cursor out of that box, you notice that the values here change. So SAM automatically figured out how many modules and inverters I needed in my system to build a 100 megawatt system. And that's because I'm in the specify desired array size mode. If I wanted to specify the numbers of modules and inverters myself, then I'd change to specify numbers of modules and inverters mode. And then I can type in numbers here. So you've got two different ways you can specify the PV system size. And SAM is building the PV system of modules and inverters that I've specified on the module and inverter input pages. So if I scroll down here to the module page, I can see that we're using SunPower 300 watt module. But there's a drop-down list of modules, so I could choose from any of these other modules in the list. And I'll come back to the options for modeling modules and inverters in a moment. I just wanted to show you that we're building a system from components that you specify. And the default inverter is a Solaron 330 kilowatt inverter. When you choose modules and inverters from this list, SAM is populating these parameters from values in the database. You can't change these values. They're not, even though it kind of looks like you can edit them, you can't. These parameters are based on field tests, so there's no real way for you to come up with your own parameters. I'll come back to that when I talk about the component models in more detail in a moment. So right now what we're trying to do is compare a PV system to a Trough system, and I needed to build a 100 megawatt PV system, and there are some other inputs I could change here. For example, the tracking option here is important, and by default, it's for utility case, it's a one-axis tracking, which I think is appropriate. So I'll keep it at one axis, but the tilt angle is 0 degrees. And if I leave it at that, that's going to give me an unrealistic output, because it's more likely that for a project this size, I'm going to try to tilt the array at a more optimal angle. So I'll just put 30 degrees here for now. But that's something to note. That's an example of a default value that is probably not appropriate. So it's important to at least do a quick review of your assumptions before you run the model to make sure that you're modeling the system that you intend to. There's some other options here, shading, which we'll get into if we have time later. Shading by default is disabled, so I'm not going to worry about it. And I'm just going to go with default values for the costs and finance assumptions. So now if I run the model, I can do quick and dirty comparison. Let me move my PV commercial case out of the way here. So I just drag the tab over to the right. And I can see that my PV system produces 242 million kilowatt hours compared to 359, 360 really, for the Trough system. So the Trough, I get a little more energy out of the Trough system, and I can also compare the economic metrics. So the PV system requires a PPA price of 12.6 cents per kilowatt hour compared to 29.5 cents per kilowatt hour for the Trough system. So the PPA price is determined by the annual output of the system, but also by the financing assumptions and the cost assumptions. So I think we have, if we compare the financing inputs, so I just switched to the financing page for both cases so that I can compare my inputs. I can see that there are some differences between the two. There's a sales tax for the Trough utility, which isn't there for PV, for example. But more importantly, we've got 0.6% escalation rate for PV and 1.2% escalation rate for Trough. We've got a 50% debt fraction for PV and 40% debt fraction for Trough. Those are factors that are contributing to the difference in cost of energy and PPA price for the two cases. So if you were going to continue along with this comparison, you'd want to make sure that your financing assumptions were either equivalent if you thought you could get the same financing for the two projects, or that they were appropriate for the financing that you expect to get for the projects. So the quick lesson there is to not to take these results at face value. The fact that I just ran this case by changing a few inputs from the defaults, and it's showing me that PV is quite a lot cheaper than CSP, doesn't necessarily mean that that's the case. You have to go through and check all your assumptions. And I say this because we do get a number of requests through user support and other channels where people are assuming that this kind of a quick analysis is valid and somehow represents either an NREL or DOE position, and I just want to make clear that that's not the case, that the default values here are just representative and not your responsibility to take ownership of their values so that you understand the significance of the results.